Hello everyone, welcome to the video solution for Edexcel past paper. This is Edexcel IAL Physics Summer 2018 Unit 2 Part 2. So let's start. Question number 12. Chemists use flame test to identify the presence of metals in a substance. The substance is heated in a flame and the resulting color of the flame is an indication of metal present. Sum of energy levels for an atom of a particular metals are shown. So these are energy levels in electron volt. An electron in the atom is excited to the minus 5.5 electron volt energy level. The electron then makes the transition to the minus 6.65 electron volt energy levels. Calculate the wavelength of the radiation that would be emitted as a result of this transition. Meaning some atom is excited and the electron is in level of energy 5.85 and then it jumps to the lower energy level, and you know that when electron comes from higher to lower energy level, this transition gives out some radiation or some electromagnetic radiation of wavelength lambda that you need to find. So you know that energy is HF, and this energy is the difference between the two energy levels, and F is C by lambda, because you know that this is C is equal to F lambda. So F is C divided by lambda. So if you make F as a subject, so F is equal to C by lambda. So you can replace F. E is equal to H C by lambda. That means wavelength lambda is equal to H C by E. You know the Planck's constant. You also know the speed of light. The only thing that you need to figure out is the energy which is emitted from this transition, and this E is the difference between these two. So you can say that E is equal to 7.65 minus 5.85, and the answer is 1.8 electron volt. But you need to convert this electron volt into joule. And how do we do that? We say 1.8 into 10 raised to the power, 1.8 into 1.6 into 10 raised to the power minus 19. This is the conversion factor from electron volt to joule, and the energy is 2.88 into 10 raised to the power minus 19 joule. This is E, and then you can plug in the value of E, H and C in this equation. So lambda would be equal to 6.906 into 10 raised to the power minus 7 meter, and you can, if you wish, you can round it off to 6.9. so you can round this off and you say it is 6.9 or 6.91 10 to the power minus 7. So this is the wavelength. Part B, explain why substances containing different metals will produce different colors of flame. Most typical question. So we have a typical answer for these. Some keywording that different metals have a different energy level. Only certain transitions are allowed or permitted in any given transition element, so which gives out a particular wavelength. Question number 13. Polarizing filters are often used when taking photographs outdoors. Light from the sky is partially plane polarized. Light from the sky is partially plane polarized. A polarizing filter can be placed in front of a camera lens to make the sky appear darker. The intensity of the light transmitted through the polarizing filter is reduced compared to the intensity without the polarizing filter as shown. Okay, so this is a diagram. Explain what is meant by plane polarized light. A typical definition of polarization and plane polarized light, that the oscillation in one direction or oscillation in just one plane containing one plane, and this oscillation also contains direction of the propagation of the wave. Part B. The light from the sky is transmitted through the polarizing filter into a camera. As the polarizing filter is rotated, the intensity of the light transmitted through the polarizing filter varies, as shown. So in this diagram, clearly you say that as the filter is being rotated from 0 to 90 and 180 and so on, so the intensity of the light is continuously decreasing till 90 and then keeps increasing. So the reason is uh, when the light is parallel to the filter, so you can say that, suppose this is the, you know, crystal. So if the wave is coming parallel, something like that, so it will pass through the filter. But what if the filter is, you start rotating filter in any direction, like you say that the filter now is something like this at 90-degree rotation. So from 0 to 90-degree, amount of light passing through the filter starts decreasing. That's why intensity decreases when filter is rotated from 0 to 90-degree, and then again starts increasing when it's continuously rotated from 90 to 180-degree. So you say that the light which are parallel to the filter transmits, that's why we have a maximum. But as the filter is rotated, the intensity keeps decreasing, and then when the wave is perpendicular to the filter, then it stops and we have a minimum intensity. And you say that the intensity is never zero, cannot be zero in any rotation. Why? Because light is there is no completely polarized light. So complete light is not stopped at the filter. So you always have some amount of light passing through the filter in every rotation. That's why intensity never zero. So point number 1 and point number 2 and then point number 3. Okay, part C suggests why the cloud don't appear darken as much as the sky when viewed through the polarizing filter. So the reason is the clouds, the light coming from the cloud is not plain polarized light. So it is not plain polarized light. That means light coming from cloud is unpolarized light. That's why they don't appear darken. Question number 14. The photograph shows an iceberg a beam from a beam of light from the sun travels through the top layer of ice and is incident on an air bubble. The diagram shows a path of two rays light within the beam, ray A and the ray B. This is the diagram. So this is air bubble and light is coming from that direction, and these are two rays, ray A and ray B. The refractive index of ice is 1.31. Calculate the speed of light in ice. Okay, so we have a two different medium interacting. The light is interacting or entering from one medium to another, or maybe you can say reflecting from one medium to the other, whatever you say. So if we have a two medium with different refractive index, then we have a formula in terms of speed of light is n is equal to v is not a standard symbol, but I can write VO over V. So this VO or V naught is speed in air, and this is speed in other medium, and n is the refractive index of that medium. So you can just substitute the value and you can say, okay, that means V is equal to V naught divided by n. So if you substitute the value, you know that V naught is 3 into 10 raised to the power 8 divided by n. N is 1.31. So V is 2.29 into 10 raised to the power 8 ms minus 1. This is the speed of light in ice. Explain why ray B follows the path shown as it enters the air bubble. So if you see the diagram, the ray B follows the path. So ray B is incident on the point at that point and then entering into the air bubble. So why it is happening? Because light that is entering from ice to the air bubble, the incident angle, this is incident angle I. This incident angle is less than the critical angle. That's why the rays transmits into the air bubble. So incident angle is less than the critical angle. So the velocity is increased and the refracted rays move away from the normal. That's why it is behaving or it is entering like that, because of this. Part C. Ray A is totally internally reflected at the surface of the air bubble. Determine the minimum size of the angle. Okay, you need to find the angle. So since sine C is 1 upon n, so you can find C, the minimum angle, which is the critical one. So C is equal to sine inverse of 1 upon n. So C is equal to sine inverse 1 upon n, and n you already have the value of n, so C is 49.8 degree, or if you wish you can write as a 50 degree. So this is the angle. Question 15. The graph shows how the current I through the filament lamp varies with the potential difference V applied across it. Explain the shape of the graph in terms of particle behavior. So what is happening here? If you see the graph, as the voltage is increased, then amount of current is also increased, and due to increase in the current, the temperature T is also increased, and the increase in the temperature causes lattice ion to vibrate with a larger amplitude, causing more collision between the electrons and the lattice ion. And the rate of and if you see, as the voltage is increased, so rate of increase in the current is decreasing. So current is increasing, after which the current is increasing but with the less rate. See if you are okay with this statement. Question number 15, part B. The current potential difference graph for a particular filament lamp is shown below. So this is current voltage graph. The filament lamp is connected across a battery of EMF 6 volt as shown below. Okay, this is the diagram. This is the circuit diagram, and the voltmeter reading is 4.2 volt. Determine the internal resistance of the battery. So if you recall, the internal resistance is related with the equation E is equal to V plus IR, and this is the R that you need to find. This is the internal resistance you need to figure out. For this internal resistance you need EMF, which is 6 volt. It is given, this is your EMF, and V is 4.2, and then you need to determine amount of current at this voltage 4.2. so this is 4 and this is 4.2, and this 4.2 you have this amount of current, and if you estimate the amount of current, so you can see that at this voltage, voltage 4.2 volt, amount of current I is around it is in milliampere, it is around 510, I would say, milliampere. So now you can make a small r as a subject, so r is equal to E minus V divided by I. You just substitute the values. E is 6 volt, V is 4.2, I is 510. But remember, don't forget to convert milli into milliampere into ampere. Milli is 10 to the power minus 3. If you substitute this value, your internal resistance would be 3.52 ohm. Question number 16. The quality of sound heard by a listener at a concert depends on the design of the concert hall. Okay. Two loudspeakers S1 and S2 are connected to the same source. They are placed a small distance apart in a concert hall. The loudness of the sound heard from the speakers varies through the concert hall. Point A is 303.10 meter from S1 and 4 meter from S2. S1 and S2 emits a sound of frequency 567 Hz. Explain why the sound heard at A will be quiet. Your answer should include a calculation. Speed of sound air in air is 340. So this is the point A. So it's all about interference of the waves. So if the sound waves coming from S1 and coming from S2 are meeting at A or interfering at A, so whether if at A you have a constructive interference, then you will hear a sound. If there is a destructive interference, you cannot hear the sound, and you need to show that at A you have a destructive interference, because they are saying that A will be quiet position, so you cannot hear voice or sound at A. That means there must be a destructive interference. So how do we do that? First we are going to find the path difference from S1 to A and S2 to A. So if you find the path difference, I'm writing in short, PD, path difference is 4 minus 3.1. That means 0.9 meter. This is the path difference. Now let's figure out the wavelength of the sound emitting from the source. So wavelength is lambda is equal to velocity divided by frequency, and velocity is 340 and frequency is 567 Hertz. So lambda is 0.6 meter. So this is the wavelength and this is the path difference. Finally, you can do one additional step if you wish. Otherwise you can see 0.6 and 0.93, there is a difference, path difference between these two, and how large and how small the path difference compared to the wavelength. But the easiest way is you divide the path difference with the wavelength, and it will give you a number which is 1.5. That means 3 by 2. So you can see that the path difference between S1 and S2 and between these two, the path difference in terms of wavelength is 3 by 2 of the wavelength. And 3 by 2 of the wavelength, this is the condition for destructive interference. That's why A is place of a quiet position. The formation of standing waves. The formation of standing waves within the concert hall may also create points where the sound heard is loud or quiet. Two methods used to prevent the formation of standing waves are using soft fabric on the walls or using tiles placed on the walls at varying angle. Suggest how each of these two methods reduces the formation of standing waves. So if you are using curtains, then the curtain absorbs the wave. That means it will not be reflected. So the formation of standing waves will be less. And if you are using tiles, that means the waves is reflected in a different direction. So chances of interfering with the incoming sounds will be reduced. That's why we can reduce the formation of standing waves. So meaning curtains can absorb the sound waves, so chances of interference reduce, or tiles reflects wave in a different directions. Thank you, madam. Thank you very much for this video. Have a nice time.